Great.
We have two parts today. The first part we will know more about the SEG software interface and toolbars and how we can deal with that. After that, we will make a complete demo from scratch for horizontal visit, up to making the fabrication drawings for this equipment, inshallah. For part one, we will discuss the SEG software user interface, the available modules in SEG, and how we can create those modules, the project data and how we can deal with it, equipment design data and settings, main elements, the main elements which make the main components of the equipment, like head, shell, cone, body flanges, and the attachments for main elements. Regarding the user interface, we have right here at the top the main tabs, which includes file elements, assembly, edit, setting, and tables. And we will discuss the orders or the buttons in each button or in each tab of those. Here on the right hand side, on the left hand side, we have the tree view. In this tree view, which is the SEG tree, includes the equipment information and the project information. We have some levels here, and we will discuss the levels of the tree. On the right hand side, the toolbox, which includes the elements of the equipment. When you select the vessel, for example, you will get the main elements right here. And if you select main element like head or shell, you will get the attachments of this element on this toolbox. Here on the middle, we have the main area. In the main area, you will find the information of the selected node. For example, if you select the project node, you will get the project information in this area. And if you select the vessel node, you will get the design data information. If you select any other node like cone or shell or head, you will get the information of this element right here. Below here, the license period of the of your license, including the end date. The user interface toolbars here for the element, you will find those orders or those buttons for each tab. For files, for example, you can start a new project or open an old project. You can save your current project as another project with the same with another name. You can close or exit from all the application. This tree save button, you can use it in case of importing MDB file and some other features. Here on the elements tab, you will find the elements of the equipment, and we will discuss this in detail. For the assembly tab, you will find the button for starting the assembly to send information to Autodesk Inventor software, and during running you can stop the running at a point. After that, if you would like to complete or modify, you can click on start to proceed your assembly again. On the assembly tab, you can start exchanger module or pressure vessel module. Here, this button for the nozzle opening. If you would like to make a nozzle opening in shell courses and head plates, you can do it from the assembly tab by using opening. You can create sheet metal flat pattern for all sheet plates in your project by using this feature, which is create flat pattern. For storage tanks, you can use shell development to make shell development for shell plates of the storage tank. It's only for storage tanks. Update item number button. This button is very important to update the item number of all elements after creating the bill of material of your equipment. To send all updated item numbers to the inventor elements in your project. If you would like to stop this update, just click on stop, like start assembly and stop. This for update item number and stop the item number. Here, mass precision. If you would like to minimize the precision of the calculated mass from Autodesk Inventor, you can minimize it from here. For example, if you would like to minimize the precision from 5 to 3 or 2 or 1, you can change it from here, from this form. You can save active document. If you open a new part, a new assembly, for example, and create something during your work, you can make save as from this document or save this document by using this button. If you are open more than one document, you can save all of them by using save all documents from here. This is a calculator for the arc length, and we will know more about it. From this button, you can open an Autodesk Inventor file from another project or any other path, like drawing part assembly. You can open it directly from here if you would like. You can save as the current element on Autodesk Inventor. You can save it, or save copy as from the current element that you open it on Autodesk Inventor. On the same button, which is assembly, you can make a parametric relationship between two parameters in two different elements, or on the same element. So you can make a parametric relationship. From the edit tab.
Ahmed,
Yes.
before you move on to the next this thing, I have a query regarding the step. So what's the difference between open an inventor and the open icon on the first particular, the file menu? What's the difference between the two?
Again,
There's an
please.
open icon on the first. Yeah, and what is the difference between open and inventor?
No difference. If you would like to open it directly from SEG, it's just an option. If you would like to open it from here.
Okay.
No difference between it. If you open it directly from Autodesk Inventor, it's the same. Okay, is that okay, or you still?
Yeah, that's okay.
Okay. From Edit tab, you can make some orders. The most important orders here, the Reset Inventor Model. By clicking on this button, which is Reset Inventor Model, you will delete all inventor elements, parts, assemblies from your model. In this case, you will need to come back to Assembly tab and start your model again. Sometimes during your trying, you may need to repeat your model again. So if you would like to make this, you can reset inventor model. Another order here, which is reset inventor item. Usually you can use this order in case of making some changes by hand in an element. Like, for example, if you modify something in the head or on a David or something like that created by SEG library, and you make some changes manually. After that, you cannot make flip back or make undo for your changes. So by clicking on Reset Inventor Item, you will delete this item only. When you click on Start button to repeat the modification. Okay, so if you make some changes on the element and you would like to delete this element only, by selecting the node from the tree and by clicking on reset inventor item, you will delete this element when you create on start again. Reset changes, this feature we will discuss it when you click on save button, for example, and you find that you will not need this change. So you can make a redo by reset changes on this button. Import access file. You can import the access database file which is supported from VDLF from here, or you can use it directly from the shortcut menu. On the vessel setting, on the setting tab, you will find the equipment setting. From this button, you can define the vessel position, direction of the assembly, the dimensions of delivered plate. The skin, you can change the SEG skin. You will find many different skins. You can select the suitable skin for you to use it in your application. The app setting, in the app setting, many different options in this setting to define if you would like to make the size of the nozzles appear in DIN or NBS, for example. If you would like to make a preview for elements or make a rendering for elements during creation or not. If you would like to make it in behind, it is a default, but if you would like to make it appear during the creation, making a preview or rendering for elements during the creation, you can do it from here, and many different options regarding the bill of material. Here, the reset system file, this button, if you install SEG for the first time, you will need to reset system files at the beginning before starting any project by clicking on this button. It's for one time, only after installing SEG for the first time. You can make a backup from your project and restore this backup from here. You can define a border from the standard borders in SEG. The same button here for arc calculator, which is on the assembly tab. The same one here on the setting. A custom drawing, from this feature you can import your custom IDW drawing to use it as a reference drawing in SEG. Anytime you will need to create a new drawing, you will SEG will come back to the reference drawing that you import and use it in the final drawing. The tables, in the tables tab, you will find the bill of material table, which includes all elements in your project, not on the vessel only, in all project. For example, if you have 2 or 3 vessels in your project, they will appear in the bill of material here. The coupling table, nozzle load table, nozzle table, flange table, gasket table, fitting table, pipe table, and the nozzle orientation table. And here the cost report feature, or you can make a estimated material cost report for your equipment or for your project by defining the cost of each material per ton. Here in the user interface, we will discuss some important features on the SEG. One of them is the profile. By defining the profile, here the information of the profile, when you send us an email by using the bug report, those information will send to our technical team to be able to return your reply, So those information like your email, your name, and your phone number are important to be written in a correct way, because when you open the report bug, for example, if you would like to send us an issue that you have, we will those information will be sent by email to us. Okay, another two important tabs here. The tutorial button here, in the if you click on the refresh tab at below here, you will find the some tutorial videos for SEG, and you can select from them, and you can play it on the SEG application directly instead of opening a browser or something like that. So you can run the tutorial directly on SEG platform, or you can open the YouTube channel directly. So if you click on this, you will open the browser, and another important button, which is templates. Here you will find some standard or pre-built projects for real projects. You can select one of them to know how this project is built. For example, for this slug catcher pressure vessel type, you can know how this equipment is built by get this project and select the allocation for this one. When you open this project, you will check the tree of this element and know how each element in this tree is done and built, and how you can make the complete project simply for those four vessels right here, or some simple vessels like this small receiver, for example. You can check how you can make an overlap between the shell and head. You can figure from this images that this head is inside the shell. So when you create this project, you will know how you can make an overlap between the shell and head, for example. So in each sample of those, you will know some important new features in SEG by creating a new project and from this template, and to study how it's created. Okay, so now let's back here. From the setting tab, you can change the skin of the application. For example, here if we go to the setting, you can find that you have many different settings. If you change one of them, you can figure that the colors and the background of the application will change. So you can select the suitable skin for your application, which suits your requirements. Here we will discuss the SEG modules and the available modules in SEG and the difference between them. For the first module, which is the overall module will make all features for all other modules will appear inside. Like for heat exchanger, for example, you will need a tube sheet, expansion joint. So those elements will not appear in case of horizontal vessel or for vertical vessel or storage tanks, for example, because those features are mainly related to heat exchanger. In case of using overall, all features will appear, like the duct features, storage tanks features, roof, bottom plates, radial roof, the annular blades, all of that will appear on the overall module. So here you can figure that we have 7 different modules. The first one, which is the horizontal, vertical pressure vessels, heat exchanger, ducts, storage tanks, spherical tanks, and equipment piping. By defining the project name and the project location, you can select the suitable module from here. If you would like to use many different modules at the same time, so you will make the overall. The project data. Project data will be separate in 3 different levels. The first level, which is the project level, the first node here. Okay, and the project level, you will define the project information like project number, project name, plant name, client, location, manufacturer, order number, and some other information. After defining it, you can click on Save to save those information for your project. Those information, some of them will appear on your drawing title block, and they are sent to the drawing information. So in case of making your title block, your own title block, you can make a relationship between texts that you entered in your title block and those parameters here. So anytime you send information from your project, it will be reflected directly to the drawing. For example, in your title block, you will need to link between the project name and a text in your title block. So you can make a text with a relation between this parameter. So anytime you will modify this parameter, it will reflect directly to your title block. Okay, and we will discuss how we can do that. The equipment design data. The second level, which is the equipment level, in case of selecting the equipment, you can define the design data of this equipment, like the design pressure, construction code, design temperature, external and internal design pressure and temperature, maximum allowable working pressure, and many other fields. You can select between them from those check boxes here on the right hand side. So if you select this checkbox, this field will be saved and exported to the drawing in case of exporting the design data table to your drawing. So this field will be exported in case of selecting this checkbox. If you don't like to export one of those information, you will need to deselect this checkbox. That after that, click on Save to make this field as not used field. And if you would like to define the new field by using Add Row, or directly you can double click on the cell and modify the information. Another option by importing the information by using the export import from cell sheet, and this button is a new button here. We will discuss it on the demo, inshallah. So many different options on the design data. On the same level, which is the equipment level, you will need to define the vessel setting. In the vessel setting tab, you will define the position of the vessel, it's vertical or horizontal or sloped, the direction of the assembly. In case of horizontal, for example, you will define the direction of the assembly. If you would like to make it from the left direction to right direction, or from right to left direction. In case of vertical, you will need to define the position or the direction of the assembly from bottom to top, or from top to bottom. Okay, here on the units, you will select the suitable units in your project, if it's in millimeter or English units. the details of the equipment, like equipment service, equipment tag, and serial number. The equipment tag is the same of the vessel name on the tree. So if we come back to the first slide, the name here of the equipment, it's the vessel tag. So if you change the vessel tag, the name of this equipment will change here. That's the tag number. Okay. Here for the delivered blade data, you will define the delivered blade dimensions in your project. And this field is very important because SEG will use it to calculate the circumference shell course length and calculate how many sheets will require to create this circumference. And SEG will use it to in case of making a roof plate arrangement or bottom plate arrangement. So those fields are very important because they will be used on the calculations in SEG.
Ahmed, can you go back to the previous slide?
Again, please.
Yes, we have a query regarding the delivered plate data. So here we understand that the you can give only one particular dimension of delivered plate. What if we have two different dimension of plates that we are using?
Here you can define only one delivered blade dimensions because SEG will go to one reference to know how which blade you will use in on shell, or you can define only one delivered blade dimension.
No, so can you see what I understand is when we are defining the individual shell courses on the actual equipment, we can define the length of the shell courses there, correct?
Now the shell course, the delivered blade.
When you are modeling that. No, that's my query is when you are actually modeling the equipment using SEG, there we can define the length of the individual shell courses, correct?
Yes.
And so what is the advantage of this particular tab?
For example, if you have a large diameter vessel, let's say 5 meters, for example. Okay, so the circumference, if we come back here and open the calculator, or open the this arc length calculator, if we have 5 meters diameter of the vessel, okay, and so let's calculate the arc length, the total circumference length here. You can figure that it's 15 meters, okay, 0.7. So that means if you have a blade with 12 meters, if we have a blade with 12 meters, it will not be enough to make the total circumference of the shell. So SEG directly will calculate the required sheet to complete this length. Okay. Now you get it.
Okay.
Okay. In case of making okay, so sorry for that. Another thing here for the roof plate arrangement, for example, here the blades which are used on the roof blade or bottom blade, those plates lengths and widths are required to make this arrangement. So this information is very important, which is the delivered blade dimensions, to make this arrangement automatically for the roof and the bottom plates. Okay.
Okay.
Okay, now for the main elements, you will find different main elements. You can use it to generate the main equipment body. Here, the most important elements at the beginning of the main elements tab here, like shell and head. And in each element of those, we have many different configurations and the types. Like on the head, for example, we have more than 15 types of heads, like hemispherical head with negative straight flange, ellipsoidal head with crown and the knuckle radius, conical head with closed end, conical head with open end, flat head end blade. You will find many different types on the head. The same for shell, many different types of shell, and we will discuss the difference between them. Cone, the cones, standard flanges, designed flanges, which is the body flanges. You can use it on heat exchangers, on body flanges, on vessels. Blind flanges, flanged connections, which makes two connected flanges in one time with a gasket. Tube sheet gaps. If you would like to make a gap between elements for a weld preparation, you can make this gap by using this element. Standard reducers. Those are the fittings group. You can make standard reducers, elbows, keys, threading coupling, X, nibble, plug. For other elements like gasket with bus partition, expansion joint, Y joint for the skirt as a welded part, valve, manometer, dump, end closure, agitator, end blade, roll section. And for the ABI elements, you can create the annular plate, compression ring, radial roof, dome roof, arranged roof, dome, arranged plate, arranged sloped bottom. For spherical elements, you can make the spherical tank end and spherical segments. For ducts, you can make inlet and outlet flange duct, rectangular duct, and inside each element of those, you will find a large number of different configurations for each one of them. The attachments. Here, if you create a head, for example, in your tree, and in case of selecting this head, which is on the third level on the SEG tree, you will find on the element tab many different attachments for available attachments for this head. For example, in case of head, you can, when you select it on the tree, you will be able to add a skirt to this head, add support pipe or support beam to this head, add many different type of nozzles, like nozzle with external projection, nozzle with internal and external projection, which is head nozzle type B, welded nozzle, coupling nozzle, stub outlet. You can add some other attachments like impingement plate, vortex breaker, front pass partition, clad. You can add platform, external reinforced pad, insulation clips, insulation. You can add different types of lifting lugs to this. In case of shell, for example, if you add a shell and if you select it, when you open the element tab, you will be able to add many different attachments to this shell. Like on the support group, you can add saddle, stack the saddle, legs, plugs, skirt, anchor chair, many different types. The same for nozzles, lifting lugs, and the external attachments like adding a name plate or external stiffening ring, insulation ring, many different elements. For the internal attachments, the same for the vertical and the for the platforms and colors. Now we will make a real sample in this training. We will create, inshallah, a horizontal pressure vessel, and we will know how to define the project information and the design data of the equipment, and how to define the setting of the equipment, how to create the main elements like head and shell and select the suitable type for our case, creating a support saddle, how we can create two saddles. They are the same on all dimensions except the location of the saddle, and we will make one of them is a sliding saddle. So how we can use the same option. So in this step, we will know how to use the same as option. Create head nozzles and some attachments. How to create shell nozzle and some other attachments. How to make a nozzle rolling, creating 2D drawings on and detail drawing and GA drawing. So in this demo, we will make this equipment with a diameter 1 meter 0.5, the ellipsoidal head dimensions, the shell lenses. We will make 3 shell courses. One of them is 2 meters, 1.4 and another 2 meters. We will add 2 nozzles on the this head. One of them is 4 inches and the second pipe is 6 inches. Manway on the right head, we will add manway with 18 inches on the right head. The support saddles, we will add nameplates, lifting plugs, boot with a forged hub and the lips to the middle shell course. And after that, we will add a drain to this bottom head and add a vortex breaker. And we will add 36 nozzle inches on this shell course, and how we can add trips to this one. So now let's come back to SEG and start creating our new project. From here, we will click on New button, and we will define the project name. And select the location. Let's add it on the desktop. Now you will be able to select the suitable module for your case. For here, we will select the overall project or horizontal pressure vessel, for example. In case of selecting horizontal pressure vessels, the other features for storage tanks or ducts will not appear. So you select horizontal pressure vessel and click on Finish. Now SEG will start creating the new project and create the files. Here on the SEG tree, you will find on the middle area, you will find 3 areas, the tree view. So you can move it and put it on the suitable place for you. So let's add it on the standard location, which is the left hand side. The same for the toolbox, you can move it anywhere, and for example, let's add it to the right hand side, and here the middle area for defining the element. Now let's select the project and let's define the project number. Now we will define the project number here, like that. And from the project name, let's define this name as plant name, client and owner, the location, manufacturer, the order number, prepared by, checked by. After that, we will fill the other data and click on save. Now the data is saved for the project. Anytime you will come back to the project by clicking on another node and come back to the project node, you will find those data are saved. Now we will rename this equipment, give it a name, and we will define the design data for this equipment and this. Now we will rename this bezel as EA 100, for example. Now you need to make a refresh by selecting the node again to refresh this form. Now we will define the design. We will make some other different options to know how we can deal with the design. The first option, you can deselect all checkboxes and select the required fields only, like the construction code, and now you will define the construction code, for example, and like that. For example, for the internal design pressure, you can remove the second unit, for example, and define the value and make it for only one unit and click on save. So that's a way to define the design data. Okay, after that you can click on save to save the project information. Now anytime you will come back to the project data, you will find that the saved data are saved. So now we know how to select the cell itself and redefine it and select the required field only. You can add a new field if you would like the designer, for example, or the window tool, for example, uniform building tool, for example, here, and the units you can make it as only dash like this. So you can figure that we have a new field here for the window code like that. All cells should be include a value. So if you have a value with null value, you can write it as null or make a dash like this. Because if you, for example, if you would like to add a cell without a value, you will receive that you will need to fill this field. Another option to fill this design data by creating an Excel sheet and import it to SEG. So now let's create an Excel sheet here. So we will open the design data in this Excel sheet. Now we will need to fill 3 columns only and directly with the data. Yes. So for example, we will need to add the construction code, for example, directly. So it's ADI and this cell is empty. Now the second field will be design pressure, for example, and support like that. Okay, now you will say, so you will need to fill 3 columns like the same on the design data. Okay, so you will need to fill item description, the value, and unit. And from here we will import this Excel sheet. So we will import the design data like that. Now you can figure that we import the design data which is created on the Excel sheet. In case of save, you will save those information. In case of moving to another node and come back without saving, everything will come back again because we don't save the information. Okay, so now you know about 3 different ways. The first way is changing the value by double-clicking on the cell itself and remodify, or by creating a new rows, or by importing from Excel sheet. And now we know how to create the Excel sheet in right format to import it to the design data. Okay. In case of making a heat exchanger, you will find 4 columns instead of 3, because we have a shell side data and tube side data. Okay. Now let's add some other fields here to the design data, for example, and let's click save. So we have some information here for the design. Now we will define the equipment setting by clicking on the vessel and come back to the setting tab. Now we will open the equipment setting. From the equipment setting, we will define the equipment. Yes?
Emma, I have a query on the design data tab. Suppose now here you have listed around, you have listed a lot of parameters that you can enter in the design data. Suppose I need to use whatever you have.
Would you mind to speak slowly to understand, please? Sorry, slowly, please.
Okay. Okay. In the design data, you have listed a lot of design parameters. Okay.
Yes.
Suppose now in a particular drawing, I don't want all of this design data. I want to select only say 10 of the parameters from this list. Can I do that?
Sorry, we just say that. We just say that by selecting the required fields only. Here you can figure that we select those only instead of all.
Okay.
By selecting the checkbox on the right hand side. We discussed 3 different ways. The first way, by defining the rechange or modify the cell itself and select it from here. Now, by deselecting all, if you deselect all, so you can select the required field only and redefine the value. That's the first way. The second way, by adding your needed new values. Okay. The third way, by importing the Excel sheet directly from the Excel sheet that you create. Okay, those are 3 different ways to modify the bill of material, the design data table. This point is clear? Or
okay. Still? Yes, okay. It is clear, Ahmed. Thank you.
Okay, you are welcome. Now for the equipment setting itself, here we will define the position of the vessel. In our case, it's a horizontal vessel, but let's know more about the available options here. 2 more options for sloped vessel with a sloped angle. So if we select sloped, for example, you can figure that the angle, sloped angle will appear. In case of vertical, you can select the direction of the assembly. In case of vertical, from top direction to bottom direction, or from top to bottom. So you have 2 options for the vertical. And in case of horizontal, you can make your assembly from right to left or left to right. Okay. For units, regarding to the units, you can create your project in millimeter or in inches. For the equipment details, like the service of the equipment, and the tag number is the same vessel name, the serial number. The delivered plate dimensions should be defined in a correct way. Let's make it for example, let's make it 9 meters and 2 meters 0.4, and let's click save. Now, when we select the equipment, you can figure that on the this toolbar, the main elements here. So you can add elements directly from this toolbar, or you can add it from the elements tab at the top right here. So when you select the equipment, we will add one of those main elements. In our case here, we will add an ellipsoidal head. So let's add a head. And let's click add. Now we have this head on the SEG tree. As you configure, now we have 3 different levels as we discussed. The first level is the project level, after that the equipment level, after that the element level or the main element level. Here when we select the left head, you configure that we have the head type list, and the name of this head, it's the left head. The name of the selected element appears here below the element type, and from the list you configure that you will find more than 15 types of different heads. The first type is the ellipsoidal head, which is a half of ellipse, not including any crown or knuckle dimensions. For the ellipsoidal head with crown and knuckle radius, you configure that this type of head includes crown radius and knuckle radius. And for the red color font, for the red font here, the crown radius value is 0.9 by the from the inside diameter, and the knuckle radius value is 0.17 from the inside diameter. If you select the flat head, it is the same configuration, which includes crown and the knuckle radius, but the knuckle value you can modify it manually, and the crown radius value is related to this equation. So you will find some other types of the heads. Each one of them includes the crown and the knuckle radius according to this standard. And you can make your own user-defined crown and the knuckle radius by selecting this type, which is user-defined crown and the knuckle radius. So in this case, you can define the knuckle and the crown radius manually. A standard caps, so it's a fitting, so you can define it from here. Diffuser head, which includes a convex tool inside like this. Convex head, flat head, hemispherical head with straight flange, hemispherical head with negative straight flanges. This type usually used in Division 2 because the center line here is moved outside the head. The crown head with knuckle at the end, cone head with closed end, cone head without knuckle at the end, circular flat end, hold circular flat end. So there are many types of the heads. Let's select the ellipsoidal head type and define the inside diameter of this head as 1.5 meters, and define the thickness as 10 millimeters. Define the straight flange to be 50 millimeters. Minimum thickness after forming the head ratio, make it 1:2, and the lap length. If you would like to make this head overlap to the second head, like we discussed on the sample here on this template here, one of those samples for this air receiver, you can figure that this head is inside the shell. So if you would like to make an overlap between elements, you can define the value for the overlap of this head inside or outside the second element. Now we will leave it 0 and click on save. In the same element, you will find more options like this head. You can make it from one piece as a one part, or you can make it from two pieces like this, include a longitudinal building line on the pieces. If you take a look to the image on the right hand side, you can figure that you can make this head from two elements, including a welding line between them, or you can make it from segments like this. So you can define the cut diameter, which is the middle piece on the inside, the inside diameter of the middle piece, and you can define the number of the remaining segments, define the first longitudinal welding line orientation. But in our case, we will make it as a one piece because the diameter is not large, so we will keep it like this. Now we will add another element, which is shell. So let's add and one. When we select the element here, as we discussed, you will find the element type list. After that, the name of the element below it. And from this list, you will select the required type of this shell type. And you can figure that you have many different types, around 10 different types of shell types. The first type is a pipe. If you would like to define the shell course as a pipe, so you will select this type, which is pipe, and define the size, schedule. And if you would like to define this with a thickness, you can select on user defined thickness to be able to define the thickness of this pipe manually instead of selecting a standard schedule. Define the length of the pipe and the material of this pipe depending on the ASME section 2 part D. You will select the table. After that, make a search for the material. For example, if we search for SA15, like this, you can find the grades of this material here. You can select the suitable grade and click on done. Okay, or you can directly modify it from here by writing the material type. That's the first type, which is pipe. Now the second type, which is shell without welding lines. It's in case of making a quick estimation, and you would like to make an LBG, for example, and you would like to calculate the approximately weight of this LBG. You can make a one shell course without any welding lines with 50 meters length, for example. So it's a one element, so you will get the correct weight, the correct volume, correct values, but with a one element only. Okay, by using a shell course without any welding lines. That's in case if you would like to make a quick element without making a fabrication details or the fabrication requirements inside. In case of shell, you will make a shell from plates, so it's a sheet metal. So anytime if you would like to make sheet metal flat pattern for it, you can do that. It's not available in those first types because it's a pipe, standard pipe. You will not make a sheet metal for it. It's the same for a shell without any welding lines, so you will not be able to create a sheet metal flat pattern for it. But in case of shell, you will be able to create this shell type, which is created from a sheet metal plates. And the SEG automatically calculate the required number of sheets depending on the delivered blade length. As we discussed in case of large vessel diameters or small delivered blade dimensions, SEG will calculate depending on the delivered blade dimensions the required number of shell plates and create it automatically. And if you would like to define it as equal segments, you can make it like this from enable segments and define the required number of elements directly from here. So you can make the shell as, if you take a look to the image on the right hand side, you will find many number of welding lines. So you will define the number of segments and they will be equal on lengths. Okay, if you would like to make it from equal segments. And if you would like to calculate it automatically by SEG, you will remove this checkbox. So now we discussed the three different type of elements. Now the fourth type, which is shell to hemispherical head regarding to division 2. Here in this type, you will find you will need to define the thickness of inside diameter of the shell and the head thickness right here. So it's a new field for the head thickness, the connected head thickness, and by the same way you can define this shell from one piece or from more different pieces. Another type which is shell from different pieces, and you can figure that from here SEG will make automatic calculation and let you know that the delivered plate dimension, which is 9 meters, will not be enough to make this diameter, which is 7 meters. Usually we use this type, which is shell from different pieces, in case of storage tanks. Because in storage tanks we need to calculate the number of sheets per course. In storage tanks, the one course may include a large number of sheet plates, and we need to reflect each sheet plate of those in the bill of material. And we need to control the length of each plate of those. So in this type, if you will use a storage tank, you can define the required number of segments or the required number of plates. For example, here if we will define 5 plates and make update. Now SEG automatically calculate the last plate length. So let's define the length of each plate and recalculate. Here you can define, in this type, you can define each plate length. So the first part we will make it 4 meters length. The second course we will make it 3 meters. The third course or the third plate on this course we will define it as 9 meters. And the last one will be calculated automatically. So in this type you can define each plate on this shell course separately. Okay, all of them with the same thickness. So you can take care about the name shell from different pieces. Another type available, which is shell from different pieces and the thicknesses. So in this type, which is shell from different pieces and thicknesses, you can define each plate thickness. Usually this type is used in the first course of the storage tanks, because you may have a clean outdoor, and this clean outdoor needs a back plate with greater thickness, not like the other plates on the same shell course. Okay. Another type, which is shell from different pieces and sloped bottom. Okay, this type used on the storage tanks if you have a vertical storage tanks with sloped on one direction. So you can use this shell type from different pieces and sloped at bottom. Another different types like thread pipe and at the start, thread pipe at the end, thread pipe threaded from the two sides, connection point as a nozzle for pipe, and connection point as a nozzle from shell. Those types we will discuss them because they are important in case of if you need to make a nozzle on a nozzle. That means in heat exchangers and some vessels, you may need to make a connected nozzle to another nozzle, like a pressure gauge or temperature gauge. On the one of nozzles that you have, you may need to make a connection on. So we will use this connection point on shell to make this type of nozzle. Now let's come back to the can, and let's select shell, and let's define the inside diameter of this shell, define the thickness, longitudinal welding line orientation, the length of this shell. In this case, let's, for example, make the shell with 3 meters, and let's click Save. You will find that SEG will inform you that the delivered plate width is 2 meters point. That's the delivered plate Yes. So SEG will prevent you from saving a wrong number. The 3 meters length is not a correct number because you are governed with the delivered plate that you have. So let's click on OK and change this to be 2 meters and click on save. Here that's the gap of the weld here, and you should have a value here. It's not possible to make it 0 because it's a sheet metal. You should have a welding line. So you should have a gap value. Okay, now let's add another shell course, CAD. But in this case, we will know one new more option. If you would like to make the CAN 2 looks like CAN 1 or other CAN if you have in this list, you will select this checkbox, which is select part the same. So in this case, we will make CAN 2 looks like CAN 1 in all dimensions. Okay, if we click add, if you come back to CAN 2, you can figure that it's automatically filled with the same dimensions. Now you will be able to change it. So let's change the longitudinal welding line orientation, the length of this shell course, and click save. Let's add a new CAN, which is CAN 3, and we will make it looks like CAN 1 in all dimensions. And let's click. Now we have the second head or the third shell course with the same dimensions of CAN 1. Let's add the last head, which is the right head. And the same, we will make it looks like the left head. And let's click add. Now if we come back here, you will find those dimensions are the same of the ellipsoidal head with the same of the left head. One more option, we will discuss it here for the convex direction of some elements like the heads or flanges or body flanges. You may need sometimes to flip the direction of the flange or the head. In this case, we will leave this checkbox as it is to figure out the configuration of this head, how it comes. Now let's create the assembly by selecting the assembly tab and clicking on the start button here, and let's open Autodesk Inventor. Here you can figure that the SEG will send the information to Autodesk Inventor to start creating elements and make the automatic assembly for the equipment. And you can figure that the elements are running behind. No preview for elements during the creation. And we will discuss this option. Here if we take a section, now the main elements are done. If we take a section on the middle of the visit, here, you can figure that this head, which is the right head, takes the same configuration or the same convex direction of the first head. But we need to flip it, make it on the other side. So now we will use this option, which is flip. Now let's select the flip button, flip the checkbox and click save. Now in case of start and come back to Autodesk Inventory, you can figure that the direction of the head is changed. So that's the importance of flip direction in some elements like flanges, blind flange, head. So you can flip the direction of the element. Let's come back to the tutorial here. We create the vessel with the diameter, head, and shell. Now let's add two nozzles on the left head. One of them is a long weld neck nozzle with 4 inches. Let's add a nozzle on this left head. So from SEG, we will select the left head from the tree. Okay, and let's come back to elements. The same from here, from the toolbar. You can use this toolbar, or you can use this element directly from here. So So at the beginning, you should select the main element. So we will select the left head to add attachments to it. Now let's select a nozzle, head nozzle. So let's add N1 nozzle. And from N1, let's select the required type. As mentioned here, the type of the nozzle and the name of the nozzle, which is N1. The selected node here, name will appear. And here the available types of nozzles on the head. Nozzle from pipe, nozzle from blade, or long weld neck nozzle. Self-reinforcement long weld neck, which is long weld neck with lips. Standard forged hub, or self-reinforcement forged hub, which is forged hub with lips. Integral nozzle connected to shell, to head, or self-reinforcement integral nozzle. So let's select long weld neck nozzle, and from here let's select the rating and select the size to be 4 inches. And from here let's define the offset from bezel center line, 400 millimeters, and let's keep the orientation as 0. From here you will define the, if you would like to make it parallel or radial, set in or set on, and let's define the nozzle service as outlet, and let's click on save. Now if we open the calculator, you can define the projection of this nozzle. As you can figure, sorry, let's close this. Here, before opening this, the projection of the nozzle is measured from the shell outside surface to the facing of the nozzle. In case of long weld neck nozzle, it will be the face of the raised face of the flange. In case of nozzle from pipe, for example, it will be the end of the pipe. So if we click on calculator, you can define the projection of this nozzle measured from the seam line, not cam line, the seam line. As you can figure in this image, the projection which is measured from shell outside will be calculated automatically in this case. That's the calculated projection. So if we click on calculate, SEG will start drawing this one and calculate the projection. So the projection of the nozzle, which is the projection from the outside of the shell, will be 332.7. Now let's click on save if we accept this value, and if you would like to minimize it a little bit and recalculate like that and click save. Now you can figure this value is reflected here. Now let's click on assembly, and if we come back here, you can figure that SEG is loading something, Autodesk Inventor is loading or calculating something. That's because it's creating or make a rendering for the element during the creation on behind. And if you would like to make a preview for each element during the creation, we will make an option here by from setting tab. You will open the app setting, and from parent preview you will select this checkbox to make a preview or rendering for elements, parent elements, which is the main elements like head, shell, cone, flange during creation, and select the child preview. This checkbox will make a rendering for elements for childs like nozzles, saddles, any other attachment to a main element during creation. So let's select child preview and click on save. Now let's come back to this nozzle, which is N1, and let's define the weld setting. Here, if you select on set weld, you will be able to define the weld value, which is a fillet weld A. You can make it single or double V, but in our case it's a small thickness, so it's only single V. So you can define the value A and click save. Now if we come to tables and open the nozzle table, you can figure that we have a new nozzle, which is N1, as the surface of this nozzle is gas outlet, the size of the nozzle, the orientation, thickness, schedule, flange class, flange type, and flange facing. No blind attached. The projection of the nozzle, that's the value that we enter, the weld style, and the value of the weld style. Okay, and we will learn more how to control the those columns if you would like to control the columns and export some columns only to your drawing, not all of this stuff. Now let's add another nozzle, but this one we will add a nozzle with external and internal projection. So let's add a nozzle head type B. This type includes internal and external projection. As you can figure in N1, you have only an external connection point. So you can connect another point or another elements to the facing of this flange. You have an external connection here, so you can connect anything here, like another flange, a gasket, or the elbow. So you can connect anything to the end of this elbow by selecting the external connection and adding another element. So let's add a nozzle with internal and external projection. Let's add N2. Okay, so in this case, we will select a nozzle. You can figure that before discussing the types. You can figure that for this nozzle, you have internal and external connection. So you can connect elements to the internal or the external node of this element. In nozzle N2, let's select a nozzle from pipe. Select the size 6 inches. Let's add a rebad. Let's make the rebad width is 75 millimeters. Select the schedule of this nozzle. Define the offset of this nozzle from visor center line. Define the orientation. Let's make it 180. Define the internal and external projection. So let's define the internal projection first and the surface of this one. Okay, and let's click Save. Now, if we select the external connection of this element and click on Flange, now we will add a flange to this nozzle. So the first step, so let's close this again. So if you would like to add an element to this nozzle, add the external connection. So we will select the external connection of this node, and from here we will add a new element which is flange. So N2 flange, and let's click Add. Now we have a flange to the external connection of the node. That's the list of flanges. As we discuss the type and the name of the node, now you will be able to select from many different standard types of flanges. So let's select weld neck raised face according to ASME B16.5. Select the rating, size, the same size of the nozzle, the same schedule of the nozzle, and let's click Save. Now if we click Assembly, you will find that the rendering of elements during creation will appear because we select the checkboxes of rendering during creation. You can figure that we have built now updated, so updated and assembled with the nozzle. After that, it will be assembled to the final assembly of the vessel. The same for flange. Now the flange is connected to the end of the nozzle. Now we need to control the projection of this nozzle. We need to make this projection looks like the top one. So let's come back to N2 again, and from the calculator, let's open this calculator and define the projection to make it looks like the projection of the first nozzle, which is N1. You can figure that SEG detects automatically that we have a flange connected to this nozzle and automatically calculates the height of this flange. So if you would like to calculate the projection of this nozzle to the face of the flange from the seam line, we will write the projection value and click on Calculate to make SEG draw and calculate the projection. Now we have the projection of the pipe only. If you take a look to the image on the top right hand side, you can figure that the projection of this nozzle measured from the vessel or the head outside surface to the facing of the nozzle. So this value will be reflected automatically here to make the projection of the nozzle from the facing of the flange to the seam line with 600 millimeters. Now let's click save, and you can figure this value is changed. Now let's click start. You will figure that the projection is changing here of the nozzle. And you can figure that easily the projection become the same for those two nozzles. Okay, now let's add some internal attachments to. So let's take a section here. You can figure that we have this nozzle with internal projection like that. Now let's add a standard reducer to the inlet of this nozzle. So we will select N2, but in this case we will select inlet to select the internal connection of this one, and from elements let's add standard reducer, and let's click it. Now we have a reducer to the inlet element, and from here we will select the type of the reducer. Let's select standard eccentric cone, and let's make it 6 inches with 80 scalable, 3 inches branch, 80 scalable, and let's click save. Now if we click start, we will get this connection here for the reducer like this. Now let's add another connection like a T, connected T to this branch, and we will make another branches from the T to know how we can deal with the SEG tree and how we can control the elements inside. So from internal connection, so let's select internal again to add another element before N2 R1, which is the reducer. So let's select internal, and from here we will select T. So N2 T1. So the names, it's related up to you. You can write your names as you like, but no repeated names available. So each element should have a unique name. So let's select N2, and from here we will select equal T, for example, and let's make the same diameter of the end of the reducer, which is 3 inches, the same scalable, and let's click on save. Now let's click on assembly. You can figure that the T now is connected from the end, not from the branch. If you would like to make the connection from the branch, not from the end, we can do that by selecting the connected from branch. So we will select this checkbox to make this T connected from branch. Before that, take a look to the tree here. You can figure that you have a branch and inlet too, so you can connect elements to those ends of the T, which is the branch and the inlet too. And in case of selecting connected from branch and click save, you will figure that the connection from the two inlets only, because the branch will be connected to the reducer. So if we click on start and come back to the model, you will figure that the T now is connected to the reducer from the branch. Now let's add two elements to this T from the two ends. So let's come back to inlet 1, and let's add an elbow. So into E1, And let's define this elbow as elbow with 90-degree long radius. Define the size and scalable. Click Save. We will add another T into E2, and let's click Save. In case of before going to another step, if you select this checkbox, which is select part is the same, which will make those parts are the same, and click Add, this node will be moved to inlet 1. Like if we make it like this, you will find it comes here, not to the inlet 2. To avoid that, you will create this node like this, which is into E2. After creating it, you will make it looks like E1 by selecting same as from this drop-down list. So you will select into E1 and click Save. Okay. Now if we click on the assembly button, we will create two elbows. Each one of them will be to the end of the end of the T. Okay, now we have those two elbows right here, like that. And if you would like to control the orientation of them, you can do that by controlling the orientation of the elements. For example, for this elbow, we will rotate it with 90 degrees and click on Save. So before that, I changed the type during that. I changed it to 45. So let's make it like E1, and let's make a refresh for the view, and you can figure that it's 90-degree long radius. So we will make it like this and click Start. Okay. Now, in this case, you can figure that we change it, but it's still 45 degrees. That's because good to get this issue during the training, to show you how we can deal with this. The first step we can do it, which is making a reset element. You can figure that on SEG, we change it to elbow with 90-degree long radius, but it's still here 45. When we change it by the wrong way to 45, it's still on the 45. But how to solve this issue? We have two steps. Let's try the first step, which is the reset inventor item. Let's click on reset inventor item to reset this element only, which is this elbow, and let's create the assembly again. If we still have the same issue, we will need in this case to close. You can figure that it's changing. Okay, but if you still have the same issue, in this case, that means Autodesk Inventor still restore in the memory some information and cannot release it. So in this case, we will need to close SEG Software and close Autodesk Inventor. And from the task manager, let's open the task manager and be sure that all Autodesk Inventor instances are closed. Okay, so you will need to open the task manager and be sure that all Autodesk Inventor instances are closed. As we said, because that Autodesk Inventor may store some information in the memory and cannot release or remove it. Now let's change the first elbow again. So let's make the orientation of the first elbow like that. Now you can figure that we have this elbow like this. Now let's add a manway on the other head. So let's come back to SEG, and from the SEG tree you can figure that, as mentioned, we have different levels: project, equipment, and main element. Inside the main element you can figure that you have the attachments. Okay, I think this point is clear. Here now let's add another nozzle to the right head. From here we will select the right head, and from elements we will select head nozzle. So let's make it as a N1. Now we have N1, so let's select it from the tree. Let's make it a nozzle from pipe 18 inches. Okay, and let's add a rebate, the offset, the orientation, name. Okay, and let's click on save. Now let's add a flange to this nozzle at the external. So let's add M1 flange. And from here, let's select the suitable type, which is welding is the face and the same size, same scalable. And let's click on save. And let's run the assembly. Now we have this manway right here, and if you would like to define the projection by the same way that we did, we will come back to the nozzle again, and from the calculator we will calculate the projection of this nozzle, and SEG now calculate and give you the projection of the pipe. And if you would like to minimize it a little bit, you can do it like this to calculate the correct projection of the pipe here, which will be reflected on the projection button here, projection text box. And let's click on start simply, and you can figure that.
Emma, just a minute. What is
Yes, your question, please.
My question is, what is the use of the tab, the field called extra length on that projection page?
Okay. For example, if you have another element or another pipe between the flange and the nozzle, for example, if you have here an extra element like a pipe, for example, let's move it before the flange, move it before M1 flange. Now we have a pipe here, and this pipe will be the same here length, and let's make it with 300 millimeters like this. Okay, now if we come back to the manway and open the calculator, you can define the extra length here of the second pipe, which is connected to the nozzle, to calculate if you have an element instead of flange, for example, or elbow, something else, and you would like to decrease this value from the calculated projection of the pipe. So you will write the value of the length of the pipe right here and calculate. So this value will be decreased from the projection of the pipe. Okay, did you get it? Again, let's if you have an element after the nozzle, okay, and this element with a defined length, and you would like to reduce this value from the projection of the pipe, the projection here of the pipe, which is measured from I hope that you can see the prompt of the mouse here. The prompt.
Yes, we can.
Yes. Yeah. From the outside surface of the head to the facing of the pipe. So you need to make the projection to this point, for example, not that point. So you have 300 millimeters extra length here, and you would like to calculate this projection only. So you will add this value here after the pipe, and SEG will calculate automatically the required projection of the nozzle here. That value will calculate that value.
Okay. Yes.
Now let's add attachments to this nozzle, like adding applying the flange, a gasket, and so let's modify this value again. So let's calculate, because it's changed when we click save the projection. Now let's add a gasket. So from the other tab we will select a gasket. So M1 gasket. Let's select the suitable type of the gasket, rating and size. Write the material and click save. Now let's add a blind flange. So from here we will select blind, M1 blind. After selecting the blind, the information of this blind will appear here, and let's select the suitable type, rating, size, and let's click save. Now let's deselect this one at the beginning. After that we will select it to show you the flip direction. It's the same of the head. The convex of the head goes on the wrong direction, and we click on flip to make it on the correct direction. The same for the blind flange. In case of deselecting this, we will find the facing of the flange will be outside the gasket on the other side. So let's come back here and check this. Yeah. Okay, if we take a look to the blind, you can figure that the raised face comes out, not on the facing of the gasket. So we will need to flip this blind. So let's click on flip and click on save. Now when we click on start, we will flip the direction of the flange to make the facing on the other side. Okay. Now let's add some attachments to this manway, like hand grip, davit, and stud bolts to make it a manway. Okay. Now let's select the blind flange, and if you select the main element, which is blind flange, you will find the attachments, the available attachments. Sorry. You will find the available attachments for this element. So let's add hand grip, M1 grip. Now let's define the dimensions of this grip. Let's minimize the spacing a little bit, and let's add 2 hand grips. Let's click save. So those dimensions according to the image on the right hand side. Click save. The offset from the blind center line. Let's click start simply. Now we have those hand grips on this blind like this. Now let's add stud bolts and davit. Now to add stud bolts, let's measure first the not spacing, which is the spacing between the two facing of this one, which is with that value. So let's add stub bolt. You can select between UNC or isonauts. So let's select UNC. To find the total here. And let's click on save. Now let's start the assembly. Now we need to increase the length of this stub bolt. Okay, I make a mistake during the run, which is saving the element during running. You should wait until the assembly done to make a save for an element during running. So let's run this element. Because during running, some information are saved in the project file. So making a writing from two different sources may cause a problem on the project information. So we should still or wait until the project is send the info, until SEG send the information to the project or to disk inventor. After that, you can save. And if you would like to stop this, you can do it by clicking on stop, and you will find that SEG will end the mission of creating the element. After that, will stop automatically. It will not complete the second step, which is assembly and creating the other parts. Okay, now let's add a David to this blind. So let's select the blind flange, and from here let's add David, M1 David. You can figure that you have many different estimated configurations of David, so you will select the suitable one for you, and let's click on save, and now let's click the assembly. After creating the David, we can control the orientation and the opening direction of this. Now we send it to be assembled on Autodesk Inventor. After assembly, we can figure that the orientation of this David is not correct. We need to flip it 90 degrees. Okay, so we need to rotate it 90 degrees. You can figure that if you take a look from the left-hand side, the David hinged point is down here. So we need to rotate it 180 degrees. So let's come back here and change the orientation like this and click on start to rotate this David 190 degrees. Like that. So if you would like to change the orientation direction, instead of, now you can figure that the hinge point on the left side, and if you would like to make it on the right side, by clicking on opening direction, you can flip the opening direction. Let's discuss one more option on the setting right now, which is zoom extend option. This option, which is that one. Automatically, SEG make a zoom extend for elements during creation, and you can figure that the zoom out like this takes place when you make something like that. When SEG send or update something, it makes a zoom extend, automated zoom extend. And if you would like to ignore that, you can make it normal. So no zoom extend will take place after updating. Okay, that's an option. So let's click on that and click Save. Now if we take a close view to this one, and from here let's change the direction of the nozzle and let's click Save. Now let's click Start. The direction of the David will be changed to the right hand side, and the view will not be zoom extended like that. It's the same. Okay, and you can figure that the David direction is changed. Now let's add a nameplate to this vessel. After that, we will proceed with support saddles, nozzles, and lifting rods. Now let's select the first shell course, and from elements, let's add a nameplate. From external attachments, we will open this button and select nameplate to add a nameplate to this vessel. So from here, nameplate. And
Ahmed, we have a regarding the David.
Again, please, because I am not hearing you.
No, we have a query regarding the David assembly.
Yes, go ahead. I'm hearing you.
Okay. See, when you selected the type of David and the David structure, David assembly was created, can we control the dimensions of the David assembly, individual components of the David assembly?
Yes, this David is an estimated part. Okay, so if you would like to make a detail for it, you will get dimensions for this one. But in bill of material of SEG, it will appear as a one element. Okay, so if we open it like this, you will find this element as a one element, but you can, by using those separate solids, you can isolate them and make this David as separate elements with a different bill of material elements. But in SEG, it will appear like this. If we open the bill of material of the SEG, you can figure that the David is an assembly and the material of this one is an assembly. Okay.
Okay. So what we understand is from SEG itself, we cannot directly control the dimensions of the David assembly, correct?
Yes, you cannot control the dimensions from the David assembly because it's just you can control the orientation and the opening direction only. But if you have a standard David, you are using it, you can send it to our technical team and we can add it to the library and make an iLogic drawing for it to make the drawing of the David easily for you. It will be generated automatically after changing the dimensions of this David. Okay, we can make a support for you at this point if you would like to make a special David detail on SEG. I hope this point is clear. Hello?
Ahmed, we lost you there. Your voice is cracking.
Okay, again, let's say that again. If you have a special David, you can send us the details of this David with dimensions, and our technical team will do it and add it to SEG library to be able to use it anytime.
Okay.
Okay, it's an optional and for free. Okay.
It's optional and
for free, not paid, It's for free. Can you hear me?
Okay.
So let's complete. Come back to the nameplate again. You will find many different types of nameplates like this. Nameplate with support two plates like that, with a single web at the middle. or like that. So let's select a horizontal bracket. Let's define the length and width, the thickness of the bracket, the projection, the location, and the orientation. Let's add an ASME nameplate. And let's click save. Now let's start the assembly. Okay, so let's define this. And click on assembly. Okay. Now we have the bracket with the ASME and the client nameplates. And if we take a look to the visual assembly, you can figure that we have this nameplate here. Now let's add support saddles. From SEG, let's select the first shell course, and from elements, let's add saddle. And let's click add. Now we have this saddle, and you can figure that we have 12 types of saddles. As we discussed in our webinars, let's open 3 types of saddle. For the saddle, we have 12 types inside, and for the different types here, the main 4 types, as you know, in SEG, the web configuration is with no edges like that one. In the second type, we have a straight edge like this, and that one. But in the first type, no straight edges, and you can add outside ribs to this type. In the second type, the web configuration includes this straight edge to the center of the vessel. On the third type, the web includes a straight edge like this, perpendicular to the base plate. The fourth type includes lifting lock. In each type of the main 4 types, you can control the web bottom width. You can make it with straight sides, or you can make it with a narrow or wide bottom by controlling the BW parameter. Controlling the web location by selecting the type. So in this type, you have 3 different cases by making the web on the left or right or on the middle. The same for the other 3 types. The web bottom with 3 cases, and the web location you can control. Okay, and other options for the hole cut or the web cut in case of you have a narrow area to tie the nuts for the anchor. You can make a cut here based on the client specs. Some specs include this cut on the web. You can control the hole. You can make a straight hole, or you can make it a slot hole. And another option, you can make it without any holes by defining the number of holes by 0. If you add the number of holes 0, you will not get any holes on the base plate. Sometimes in specs, some specs, the sliding saddle not includes any hole, just a Teflon below it and flipped angles, tightening it from the outside edges here and there. You can control the direction of holes on the short side of the base plate or on the long side of the base plate. You can control the number of the ribs. So let's now come back to the model, and from here let's select the first type, which is a web on the middle, and let's define the saddle contact angle 150, the height, the thickness. Let's define the wear plate, so let's add a wear plate by selecting this checkbox. Define the contact angle of the wear plate width, the thickness of the wear plate, and the fillet on the wear plate. If you don't like to make a fillet and make this wear plate with sharp edges, just remove this fillet activation. Let's define the base plate length, base plate width, base plate thickness, the hole diameter, the hole offset from the short edge, hole offset from the long edge. If you would like to make this saddle with a sliding holes, just select this checkbox. So we will select sliding support. Make the slot length with 30 millimeters. We have 2 holes per row. Okay. Now we will select a second row to make a second row of holes. Define the location of the saddle and the orientation. The default value of orientation is 180 degrees. So if you would like to make it a hinged saddle, for example, you can make it at 0. And if you would like to make it support in a wall, you can make it on 90 or 270 degrees. Now let's add some other options. If you would like to make a cut on the saddle, by selecting the web cut, you can add a cut and control the cut height, width, and fillet. If you would like to add a mid-ribs, you can add it from here. So let's add a mid-rib. And let's control the top width of the rib. So let's make it 300. And from bottom, let's make it 300. Let's add mid-rib. Let's add intermediate rib with spacing with 700. Let's click on Save. Now let's click on Start to start creating the saddle. Now you can figure that this saddle comes with straight edges. That's because we didn't control the bottom width of this saddle. So there is an option to make this saddle controlled at the bottom. This option, which is straight side. In case of removing this, selecting this checkbox, the sides of the saddle will be straight, as we discussed here. On this type, you can make this saddle with straight sides. So if you would like to control the bottom width, make it tight or narrow, we will control this checkbox by removing this checkbox from here. Remove the straight sides and write the suitable value. Let's make it a little bit smaller than the base plate length. So this value is good. Now let's click on Save. And when we click Start the assembly, you can get the changes on the web and the outside ribs. Okay, now after creating this saddle, we will proceed with creating a new saddle with the same dimensions, but we will make it a fixed saddle with another location. Okay, so how we can do that? So let's come back to the SEG tree, and from here we will select the first saddle, but let's wait first to finish the assembly. Now the assembly is finished and the start buttons appear again. Now from elements we will add a new saddle. So let's add a right saddle. And in this case we will make it looks like the left side. And let's click add. And if we come back here to the right saddle, you can figure that the same dimensions is there. The only thing we will do, which is removing the sliding holes and change the location of this saddle to make it 440. Because if we check the total length of the shells, we have 2 meters plus 1.4 and another 2 meters. So the total length of the shell courses is 5.4. We have the first saddle on 1 meter from the left side, and the second saddle will be 1 meter from the right side. So the location will be 4,400. Now let's click on save and start the assembly to start creating the second saddle, but without sliding holes and with a different location. Now the second saddle is created. Let's close opening. Now let's add another nozzle here and add some ribs to this nozzle and add another long nozzle with support ribs. So let's come back to N1, the can one, and from here let's add nozzle. So let's add N E. And let's select the size of this nozzle. Let's make it 24. The location of this one, make it 100. The orientation, make it 0. And let's click save. Let's name this nozzle as like that. And let's add a flange to this one. And 3 flange. Click add. Select the type. Add gasket. Let's add a blind. Let's make it flip. And now let's add a nozzles to this blind flange. So let's create this nozzle first. After that, we will change the projection of the nozzle to calculate the projection from the facing to the bezel center line. After that, we will add a nozzle to the blind and add some stiffening grips to this nozzle. Okay, now for this nozzle, let's increase the wear plate a little bit and add a nozzle to this point. So let's come back to the nozzle and let's change the location and increase the wear plate a little bit. And on this blind flange, let's add a nozzle. So from here, you can add a nozzle with internal projection or nozzle with external projection only. So in this case, let's add a nozzle with internal and external projection. So let's add in 4 to this blind. So we have a nozzle on this blind like this. So let's make it a nozzle from pipe with 2 inches, and let's define the schedule. Define the offset. So let's make it on the middle of the manway or in this blind. Define the projection and internal projection. So let's make the projection with 2 meters, for example. And from here, let's add an external flange to this nozzle to define the projection of this one. So in 4 flange. From here, let's select size and schedule. And if we come back to M4 and from the calculator, we will define the projection of this one by calculating the projection of the pipe. So the value here is the projection of the pipe. Okay, so let's click on that to calculate the projection of the pipe. And the same we will do it on the nozzle here from the calculator. That's the projection from vessel center line. So let's make it 1 meter. So let's increase it a little bit like this. So that's the projection of the pipe. Let's click save, and now let's click start the assembly. The location and of the nozzle and the wear plate width will increase. After that, we will SEG will send the data of the nozzle on the blind to be generated. Now we have this nozzle on the shelf like this. Now let's add some stiffening grips here on this nozzle. So let's select the main element, which is the shell. Okay, we have a nozzle which is in 3, and we need to make some ribs, stiffening ribs to this nozzle. So let's select the main element, not the nozzle, because the attachments not include sub attachments, only the main element. So we will select the main element, and from external we will select nozzle ribs. From the external attachments, we will select open nozzle ribs to generate ribs for this nozzle like that. Yeah, we will create ribs like this to this nozzle. So from here, let's add M3 ribs and click add. Now we have those ribs, and from here you can select between 2 different types. The first type is that type, just ribs on the pipe. Another type, ribs raised to the flange like this. Okay, so we will select nozzle rib and define the nozzle outside diameter. In case of 24 inches, it's 610. So that's the outside diameter of the nozzle. So we will define it like this. And the rib thickness, we will define the rib thickness. The rib bottom width, which is that width. So let's make it little bit smaller than the bed width. The rib height, so let's define this rib height. The rib thickness, the bottom edge. Okay, so that's the bottom edge, this small edge right here. So let's make it 25. The top edge, let's make it 25. The location, it should be the same location of the nozzle. So here the nozzle, those information from the nozzle, which is nozzle OD, the rebed thickness, those are the nozzle information, and the same location of the nozzle, the same orientation of the nozzle. Now if you would like to add some cross ribs, which on the 45 degrees, if you would like to add some cross ribs, just click on this one and click save. Now if you click on assembly, we will start generating the stiffening ribs. Now we have those stiffening ribs to this nozzle like that. Let's add a nozzle with small diameter and long projection with a hilly side option. After that, let's add stiffening ribs to it. Now let's add another nozzle. So let's select the CAD 3, and from here let's add N5, N4, and from N4 let's select a long weld neck nozzle, and let's make it with 2 inches, no problem. The location, orientation, but we will make it with a hilly side option. So it will be shifted from the vessel center line, let's say 300 millimeters, and let's click on save. You can control the offset direction in the clockwise direction or counterclockwise. So let's make it on clockwise and take a look from the back view here, and let's make the projection of this one with let's save this, and from the calculator let's increase the projection like this and calculate the projection of the nozzle. Let's minimize it a little bit like this, and let's click create. Now we have this nozzle shifted from the vessel center line, and now we need to make stiffening grips to this nozzle. So let's come back to the shell, not to the nozzle. Let's come back to the main shell, which is in CAD 3, and from here let's add external attachment, but in this case we will select nozzle support rib, not nozzle ribs, nozzle support rib, and now we will know the difference between. Here, if we select this one, you can figure that you can add ribs like this to the nozzle. So for the 2 inches long weld neck nozzle, we will get the outside diameter of this one. It's 84. So let's come back here and define that to be 84. The rib width, which is the width of this rib, the rib thickness, rib angle, which is the this angle, sloped angle here. The location, it should be the same location of the nozzle and the same orientation. So if let's save this and come back to the nozzle. The nozzle location is 1200 millimeters. Orientation is 0, and it's offset with 300 millimeters from vessel center line, and that's the projection of the pipe. So let's come back here And from ribs, let's define the heli-side option. So we will define the heli-side option, the offset of that one, and let's define the projection that we get it from the nozzle. And now let's add this rib to be add one rib only. And if you would like to add another rib, so let's add the other rib, and let's click on save. Now let's click start the assembly. Now we have those ribs like this, and you can control the offset from the facing of the flange. So if we come back here, and by controlling the rib offset, which is this value, rib offset from the projection value, so we can make it like that. And if you would like to add another ribs with another angles, you can with another sloped angle, you can do that. So for example, we can do that with 45 degrees, and let's make the offset for 300. Sorry. Let's click save, and now let's click start the assembly and come back to the model again. Okay. Now we have, so you can control each offset for each nozzle separately. So you can figure that we leave this with 30 millimeters like that. That's the offset. And one of them we made it. We made it with 200 millimeters rib offset. Another one with 300 millimeters offset. So you can control the offset and the angle of each one separately like this. Okay. Now, one more important point before proceeding with detailed drawings, which is sending the item number. Here, if we open the bill of material, you can figure that SEG automatically calculate the bill of material, and you can figure that we have in this equipment 138 elements, including nuts and bolts. And SEG automatically detect the identical items, like we have two ellipsoidal heads with the same data, same weight, same material, same description, two shell cores, two elbows, all of that, and gives them the same item number. For ellipsoidal heads, for example, it gives them item number 1. So to update the item number here to Autodesk Inventor, we need to make one more step before proceeding with the drawing by clicking on Update Item. This step takes around between 1 and 2 seconds for each element on of the Autodesk Inventor. So it depends on the number of elements in your project. It may take 30 or 30 seconds or 1 minute, maybe more if you have a larger project. It may take more than that. Now we make an update item number by sending the item number to Autodesk Inventor Elements to proceed with the next step, which is generating the drawings. Now this process is done. To generate the drawings, I hope until this step everything is clear during the 3D model. And if you have any question during this step, kindly ask me before proceeding with the 2D drawings.
Ahmed, I have one query.
Yes, sure.
That is regarding the gaskets. What we have seen so far is you're adding gaskets. Is there a way to control the type of gasket? Because depending on what type of gasket you are using, your flange dimensions will vary. Whether you have an outer ring, you have an inner ring, and stuff like that for a spiral wound, or it's a cam profile gasket without the rings, all those things. So can we control that?
Would you mind to speak slowly, please, to understand you? Please? Because the voice,
Okay.
because the voice is not clear, so I would like to hear you slowly to understand. Sorry for that.
Okay. No problem. What I'm asking is, we have different types of gasket. You have spiral wound, you have cam profile, so on and so forth. You might also have an octagonal ring gasket. So when we have different kind of gaskets, can we control the kind of gasket that we are using here?
As mentioned here on when we discuss the gaskets, the available types here, it depends on the ASME types or the standard types. If you would like to define something like a spiral wound or make a detail for that, you can make it separately, not on SEG. But you can, on the remarks, define the more information about this gasket or the gasket material here on the gasket. But it's if you make a flat gasket or a ring joint gasket like this, if you take a look to the image on the right hand side, it's just some information about the gasket, not in detail. Like if you would like to make it with inner stainless steel inner or outside or in core different material, or so if you will make it in detail, it's not available here, but we can do it if you have some standard configurations. We can add it to SEG library if you send us the information about that, and we could help you to know how to add it to your drawing if you would like to make it by hand. Okay.
Okay. The next query that we have is we haven't yet touched on PVLite. How to import this thing from PVLite. So is that something that you're going to address after this, or
where is the issue, please? Because I don't understand. Where is the issue?
No, PVLite, you said that like what we understand is we can import data from PVLite software directly.
Not PVLite, from the exported access database file from PVLite. PVLite export access database file. So we read this access database file in SEG.
So are you going to demonstrate that here? How do we do that?
No. If you would like to arrange another meeting, we can do it.
Okay, fine. Okay, fine. So what?
But you will already find some tutorial videos regarding that on our channel. If you check our channel, you will find some tutorial videos regarding that, and sessions for some of our customers talking about the PVLite module and how we can deal with it.
Okay, fine.
Okay. Any issues before proceeding with the drawings?
No, we can proceed.
Okay. Now let's make the general arrangement drawing for this vessel. So from here, each node on SEG3, you can make a separate drawing for it by clicking on the node and right click and select drawing. Each node you can do that. So you can make a detail for the rib, you can make a detail for saddle, for nozzle. In this case, we will select the vessel and select from the shortcut menu, select drawing and select create drawing. And from here, let's select the drawing size. So let's select A1 from the format of the drawing, and for the orientation of the drawing, you can make the drawing landscape or portrait. you can control the location of the title block. Okay, and from the active view, you can select the required views in your drawing and the spacing between views. Here, let's select an elevation view and back view. Let's define the spacing between them with 4 centimeters. So all spaces are defined in centimeter. And for the orientation view and scale, here we will define the elevation view orientation. So let's discuss this point in detail. If you would like to, let's open the assembly again. Here, if we take a look to this vessel from the left view, here, it will be like this. If we take a look from the back view, it will be like this. So if you would like to make the elevation view, so from here, from this checklist or this list, you can select the elevation view orientation. Here, that's the elevation view. So the elevation view will looks like from left view. So the elevation view will be like this from that view, from the left view. Okay, I hope this point is clear now. And if you make it from back, the elevation view will be like that. So if we make it from back, the elevation view here will be like that. Okay, so you select the orientation view of the vessel from here. So let's select left view. From style, you can select the style of lines. If you would like to make it to make the hidden lines visible, or only the visible lines appear. Okay, here the hidden lines, and here only the visible lines. And if you would like to make the body shaded, takes a color, the real color, you can make it shaded from here. That's the location of the elevation view. And we will make some changes to know how we can control this. So at the beginning, let's make it on 1330. That's the scale of the vessel. From here, we will, all of those values can be changed after creating the drawing. If you find the scale is need to be minimized or increased, you can come back and control it from here. The same for locations. Now we will add some tables to our drawing, like the bill of material table, the design data table, flange table. Let's add the nozzle table, fitting table, gasket table. And from here, let's add some nodes. You can, there are some standard nodes you can edit or modify or delete. So if you would like to delete a node, for example, just click on delete, select it and click on delete. And if you would like to modify, just click on it, select the row. After that, click on edit to be able to edit it. After that, click on add to update that. And if you would like to import a new nodes, for example, you can do that. So let's save this and come back to the desktop here. And let's add some nodes on Excel sheet. So from here, let's add nodes. How to import a nodes from Excel sheet? You directly edit or write the nodes here. One column only one column. You will add your data like that. After that, save. Now you have the nodes. Not don't write 1, 2, 3. Just in each row you will write the content. After that, from SEG, if you open the drawing again, select the same node, which is a vessel, and from drawing, select create drawing. And from tables, we will select the nodes, and from import, we will select the nodes, the Excel sheet here. And when you click on open, you will find that do you want to delete all the nodes? If you click in yes, you will delete the old nodes. If you click in no, you will add the the nodes that you add. So let's click on no. Now you can figure that we add those nodes here. So let's delete them like that. Okay, so now you know how to add from external Excel or modify it directly from the drawing. Now let's open the welding detail form. From here you will find that you have a huge library of welding details. Just select the suitable welding details for your project. So from here we have this connection for the cone to nozzle, centric cone to nozzle, and that one. We have a bad with, sorry, we forget to make the boot. We come back here. Oh, yes, we have a boot right here. So let's come back to the model and create this boot and add a nozzle on the boot head and vortex breaker. So let's close this, save changes, and come back to the model. From here, let's select can to, and from here, let's add a new nozzle. So let's make it boot. From here, let's select this nozzle as a self-reinforcement, user self-reinforcement forged hub, or user-defined forged hub with lips. And let's define the outside diameter of this one, the thickness, the location, orientation. We will make it at the bottom. Let's change the hub height, the hub thickness, bevel height, the width of the lip. Let's make it 50 millimeters. The thickness of the insert pad or the lip. So let's make it 14 millimeters. It will be greater than the thickness of the shell. The thickness of the shell is 10 millimeters. So we'll make this lip with 14 millimeters. The fillet at the bottom and the fillet at the top. Let's make a chamfer on this edge because the thickness of the shell is 10 millimeters and this thickness is 14 millimeters. So we will make a chamfer with 4 to 12. And let's click on save. Now let's add a shell to it. So let's make it can 4. And from here, let's select shell, find the inside diameter, the thickness, and the length. Click on save. Let's add another head. So head. Click on save, and from here let's select an ellipsoid head with inside diameter and straight flange, and let's make it flipped. Now if we click on assembly to start generating this nozzle with lips. Now we have this boot assembled right here, like that. Now let's add a nozzle and add a vortex breaker, this one. So from SEG tree, we will select the boot head. Okay, so we should select the right node, which is the boot head. And from nozzle, we will select the nozzle and name it as D. It will be the drain nozzle. Make it long weld neck nozzle, 2 inches. Offset 0 from the bezel center line. Let's click on save, and from the calculator, let's calculate the projection from the seam line. It's okay for us right now, and let's click on assembly. Now we have this nozzle on the bottom end. Let's add a vortex breaker on this nozzle. Let's measure first the inside diameter of this nozzle. It's 50 millimeters, 0.8. So let's come back here and select the boot head. And from elements, let's add a vortex breaker. So from internal attachments, let's add a vortex breaker. Now let's define the vortex breaker dimensions. It's 0 offset from visual center line. Orientation is 0. Thickness is 6 millimeters. The length of this plate, let's make it 120. The height here, let's make it 50 millimeters. The depth, let's make it 65. And if you would like to make it with cut, make this depth smaller than the height. So it will not be with an edge like this. It will be with cut on this plate. The inner diameter. If you would like to add a perpendicular plate on this one, just select the perpendicular plate. And if you would like to add a cover from here and with 6 millimeters thickness, let's click on Assembly to start creating the vortex breaker on this head. Now we will take a section to figure out the configuration of this. Let's take a section here, like that, and you can find this vortex breaker inside this nozzle, like this. If we open it, you can find that this vortex breaker, you have one plate here and two other plates, perpendicular plates and top ring. If you would like to remove the cover, for example, you can remove the cover from here. And if you would like to make this with cut, make this one with cut, not with a straight edge at below here, just a cut. We will make the depth smaller than the height, so let's make the depth plus 40 millimeters and click on Save. Now we remove the top cover plate and make a cut here, so click on Save, and now we will start the assembly. Now you can figure that we have a cut here on this one and the cover plate is removed. So you have many different configurations you can control on it. And if you would like to increase this cut to make it outside the outside diameter of the nozzle, you can change the inner diameter. So for example, if you would like, let's measure this. So that's the outside diameter, sorry. Here it's 84, so let's make it 90. So inner diameter, let's make it 90 and click on Start. To make the cut is greater than the outside diameter of the nozzle. So the cut come like this. Okay. Now we have a nozzle like or a boot like this, and you can add another nozzle to this can, like in our example here. We have nozzles on this shell, so you can do that by selecting the shell itself, which is can 4, okay, which is located on the boot, and add any elements you would like to add. Now let's add some lifting lugs to this model. From here we will select can 1, and from elements let's select one of those lifting lugs. Let's select the cross lifting lug, which is type 9. So from here let's select plug 1, And from lug 1 here, we will define some dimensions like length, width, radius. If you would like to add a wear plate or cooler, we can define it from here. So let's define the length, the radius, lifting rectangular length, which is the spacing between the lifting lugs in the longitudinal direction. So let's say we will put a lifting lug here on this shell course is 2 meters length. So let's add a lifting lug on 1.5 meter, and the same here 1.5 meter from that. So we have a spacing between them 50 millimeters, like that, and so the spacing between them will be 2 meters point 4. So we will define this like that and define the offset E, dimension, thickness. So let's define those dimensions like that and define the location. So the first one will be on 150, the orientation will be 0. And now let's click on start to start assembly this lifting lug. The cross lifting lug, and let's increase the wear plate a little bit. Okay, so let's increase it a little bit because it's near to the edge of the lifting lug. Now let's remove the section view. That's the lifting lug here. So let's increase the wear plate a little bit. So let's make it like this, and let's increase the edges, which is dimension 3. Let's make it 50, and okay, let's click save, and now let's click start simply. Okay, now let's come back to the 3D model after finishing this, and let's add the other lifting lugs. Okay, now we have this one, it's suitable dimensions, suitable location. Now let's add another one on the other side. How we can do that? So it's easy. So let's select CAN 1, and from here let's select the same type, which is lug type 9, lug 9, lug 2, and we will make it looks like lug 1. Okay, and click add. But here we will select it to be on the other side. So we will select this checkbox to make it on the other side and click save. Now if we click simply, we will create a new lifting lug. Looks like the first one, but on the other side, on the counterclockwise direction of the visit. Now we have those two lifting lugs like this. Okay, now let's add another two lifting lugs right here on this area. So let's come back here and select CAN 1. Select the same lifting lug, which is lug 9, and from here lug 3. We will make it looks like lug 1, but with small change. Let's reverse the direction to make it on the other side and increase this value to make it. Let's add the length of the course. So we will add this value plus the current location plus 50 millimeters. So that's the new location of the second one. Okay, 300.50, and let's click simply. Now we have this lug right here. So I think we need to calculate again the location. I think the location we calculated in the wrong way. So here the location of this one is 1500 plus 50 millimeters, which is from here, from the center line here to this one. So it should be 2 meters plus 1400 plus 500. So it should be 3900. So we need to change this. It should be 900 like this. And let's create the last lifting lug from elements. Let's add lug 4. And let's make it looks like lug 3 in the same location, but it will be on the other side. So it's the same, but on the other side. So let's click Save now. Click Reassembly. Now we have, as you can figure, if we take a look from the top view, we have a cross lifting lug to lift this equipment from one single point. Now, as we discussed, we should update item numbers. So if we check the bill of material here, now the total number of elements are increased here. Now, to update the item number, we need to open the Assembly tab and click on Update Item Number to reflect the modification on the inventor elements before proceeding the drawing. Now let's wait seconds to finish this process. After that, we will proceed with our drawing. Okay, so let's close this simply. I think it's still updated, so let's close this and start the updating again. This step is very important in case of you will add item number balloon to the items in your drawing. Like if you would like to mention the item number for elements to refer it to the bill of material. And we will know how we can do that, inshallah, in our drawings after finishing this course. Any questions during the update? Okay, the update is done. Now we will open the drawing. So from here we will open the drawing of additional arrangement, and let's come back to the tables. And from here let's select the suitable building details that we would like to add it. Okay, and from here, let's add those details and click on Save. Now let's add another table, so like client document list. That. Okay, click Add. And for the vessel document list, we will add mechanical. Okay. Let's add saddle calculation. Let's add, and let's modify this. So edit DWG, and this one, edit DWG. Now let's close this. And from the title block, we will define the drawing name, the general arrangement, and from here we will add the revision table. So from here we will add revision 0 and issue to review. Okay, and let's click on save. Now let's delete this empty row and let's add new rows like this. And from here, from the style table, we should go to this tab and save information here. And for this tab, if you would like to make new sheets on the same drawing, for example, if you have a huge information in the same drawing and you would like to separate the bill of material in a separate sheet, and if you would like to separate the design data and some other tables on a separate sheet, you can do that by using this option. So design 1 give you 1 sheet, design 2 give you 2 sheets, and you have the ability to control the second sheet size. Design 3 give you an option to make 3 sheets, and you have the ability to control sheet number 2 and the sheet number 3, and you already defined the sheet number 1 here on this form. Now let's create the drawing by clicking on create. Now SEG will create the template and the border, changes the size of the drawing, create the views, start adding tables like nozzle table, bill of material table, filling data, adjust the location and the style of the table, now the design data table, the notes table, nozzle table.
Ahmed, may I interrupt you for a minute?
Yes, sure.
So this template that you're using, this is a default template. So can we have custom templates? Because sometimes we have our customers requesting the drawings in specific formats. So is that possible?
Yes, as we discussed on this presentation on the toolbars, if we come back here, When we discuss the toolbars or the tabs here, we discuss on the setting tab, we discuss the custom drawing template. Here, by using this one, you can import, or this feature, you can import your custom drawing. And on one of our presentations, we discuss that in deep and create a new drawing. So let's come back here. Not on this one, so it's yes. Yeah. So from this form, you have the ability how to create a new border and the title block. So it depends on your project and how you can import it, use it as a reference drawing in SEG. And we in this webinar we did a new border and a new title block and import it to SEG library to be able to use it in your project. So you will import it from this form and define some information here. After that, you will be able to use it as a reference drawing. And we could make one on this session, no problem, on this training course. Now, after creating the general arrangement drawing, that's all of that is automated up to this point. Here you can figure that the title block data is changed, like the drawing number, the job number, the location, the project name, the visual service and the visual number, the revision table, bill of material table, all of that.
I'd just like to interrupt you for a minute. Fauzan, are you available?
Yes, I am available.
Fauzan, now the point is actually a few of our members will have to leave now because the schedule time is done. So is it possible for us to continue this some other time now?
See, first of all, the session was planned just for 3 hours, which was an orientation session. So
Yeah.
I want something more than I need to check with Ahmed only.
That's what I'm saying. We like to finish this session, whatever Ahmed is trying to tell us, but unfortunately no, because we're kind of running short on time, and a few of our users have to leave now. That's why.
Okay, because see, we will complete this drawing part, and we are already doing a recording of this, right? So definitely, I will be sharing you the recording, which can be seen later as well.
Okay.
Will that be fine? Because since now he is into the drawing generation part, maybe if we can finish it, and then if someone from your team who is about to leave now, they can see it in the later stage once I share the recording. Will that be okay?
Fine. Yes, that'll be fine.
Okay.
Ahmed, in that case, my queries to you. How long do you take? It will take for us to finish the rest of the session.
Maybe less than 30 minutes, inshallah.
Less than 15 minutes, you said?
30 minutes.
30 minutes.
Half hour.
Okay.
Okay, now
please.
Yes?
Please continue.
Okay. Now, if you would like to change the scale of this view, make it a little bit bigger, so we can change it from 1 to 20 to make it 1 to 18, for example, and move this view a little bit to the left-hand side and make it a little bit down. So from here, let's come back to the drawing view again. And from here, we can change the location of the view. So let's make it 27 on the X direction, and on the Y direction, let's make it 28, and the scale, let's make it 1/18, and click on create. Now the scale, you can figure that it's changed. The location the same, so the scale here is changed, and the location of the view. Now let's add some annotations to this vessel, like the center lines or the tan lines for heads. So from here, let's select the tan line for this head like that, and for the boot head, the same for that one. On the other view, let's add some center lines. For those nozzles. Okay. Okay, now let's adjust those center lines for the vessel and for this nozzle. Now let's measure some dimensions. As we make it from the seam line, you can make it from seam line, but usually we will define it from the tan line like this. The same for that one. It will be measured from the tan line. Same for saddles. The saddle spacing. Just adding some dimensions like the inner diameter. Let's add some add a reference point to measure the dimensions. Continue. So let's measure from here and there. Let's continue like this, and let's move them down. Okay, let's move this one down here. Now, how to add a tight balloon for the bill of material? By selecting the balloon from here, and let's select item number in bill of material. And from this form, you will select the parts to define the part item number, not the structure, not the total structure. You will need to define parts only. So from here, you will select parts only and click on OK. So if we select this item, you will get the item number, the correct item number based on the bill of material of the SEG. So let's check this. For example, here we have this head, it's item number 2. So if we come back to the bill of material and check item number 2, we have one element. This element is an ellipsoidal head. It's an ellipsoidal head with inside diameter 700 millimeters, the nominal thickness 10 millimeters, the minimum after forming 8, and slit flange 50, material and weight. So let's check another element. So from here, let's check this element, for example, but you should be sure that you select item number in bill of material. If you select, for example, standard balloon, you will find it 46. So when you will check it with the bill of material, you will note this number is not correct. 64 is a vortex breaker. So you should modify it to be, so during selection, you should select it as item number in bill of material. Okay, so it's 37 now. So if we come back to item 37, Okay, it's a rib blade. Height is 250, which is 240. Thickness is 10 millimeters, and weight of this end. So you should select item number envelope material, this part. Okay, now to add a nozzle tag, you will select the balloon, and from here you will select nozzle tag. So if you would like to add a tag to this nozzle, just select the nozzle directly, and by click on Control and move, you will make it straight like this. So add a balloon like this. The same for this one. Continue. Another one here. So in case of you cannot select the nozzle, if you cannot select the nozzle, for example, in this case, you try to select the nozzle, but you are not. In this case, we select it, but in case of you are not able to select it, so let's select the nozzle balloon and select this flange, for example. So let's select the flange. After that, you can select the element itself directly like that and remove the old balloon. Okay, so let's add the nameplate, location, the balloon of the nameplate. Now let's add some dimensions for the nozzle's projections. Like that. Okay, so now you can add. So for this case, for example, if you would like to add, so this center line, we need to modify it. Sorry, it should be to the outside here. So let's add the location again, like that. And let's add the nozzle balloon number. So let's select the nozzle itself and the manway, like that. And let's remove this balloon for the flange. So we have two nozzles like that. Now, after modifying the other dimensions, you can generate a complete drawing for the equipment. If you would like to add some details in this drawing, like if you would like to add a detail for this forged hub in the same drawing, you can make it easily, and you can make it in a separate drawing in case of you try to make it like this. Select the boot node from here and create a separate drawing for it. But right now, let's add it on the same drawing. So how we can do that? If we open the assembly of the vessel, and let's open the boot itself from here, this boot, and let's come back to the drawing and add this view. So let's take a look from the top view, and let's minimize the scale 1 to 10, which is boot up detail. Sorry. Okay, so let's move this down here, and let's take a quarter section. So from here, let's take a section. Sorry, so let's take a section from the middle like that, and we will move it up right here. If you select projection like this, you will make a cut like that, but if you make it aligned, you will make aligned projection like this, quarter section like that. So you will get this section, and now you will be able to add dimensions on this view. So let's move it a little bit here, and add some dimensions to this one. So from here to there, level, and to the end, let's add the inside diameter, the outside diameter. Let's add the thickness instead of that. So let's add the thickness, the half thickness, the length. Okay, and let's add the fillets here and there. And if you would like to make a detail for this end, you can make it by that way. So let's add some dimensions here. So that's the chamfer value. If you would like to make that as a label, you can make it like this. And if you would like to make a detail for, let's say, the saddle, you can make it on the same drawing. So let's open the saddle drawing like this, and you can import a view for it right here. So let's change the scale of this one. Okay, like that. And you can make a projection from it here. And if you would like to make the all visible lines, you will make it visible from here or shaded. So it's an option. If you would like to make a section to make the base plate visible, you can make a section like that to detail the saddle. And let's add some dimensions. If you would like to make a detail for that, you can do it. So let's select the view again, select the correct view. With the scale 1 to 4. The same for detail view. Okay, so by that way you can generate a detailed drawings for it. Now let's discuss something about the detailed drawing if you would like to make it as a separate drawing. For example, let's open the fixed saddle, and from here let's click on drawing and create drawing. Let's select the size of drawing, the views. Let's make 2 views. And as we discuss here, if we open the right saddle, the elevation view, in case of selecting left view, it will be that view, but we need to make it, the elevation view, we need to make it as that view. So we should select front view. So from here, you select front to make the elevation view as a front view. Leave those values and make the scale 1 to 10. And from here, let's add the bill of material. We will not need building details or notes. And from here, let's make it saddle detail. DWG 103. And from here, let's make it revision 0. for review. Okay, let's remove this empty row, and from here we should save that and create drawing. Now we have this saddle detail with bill of material. If you would like to increase the scale and move it a little bit, as we discussed, we select the element again from the tree and from drawing. Let's move this this division view a little bit up and to the left hand side, so the scale. To discuss the location, for example, let's make it on 0 and 0, okay, and click on create. You can figure that the location of the first view, the midpoint of this view will be located on 0 and 0. So the location here from this form defining the location of the view. So let's make it on 1.5, for example, and on the y direction, let's make it 27 or leave it 25, and let's make the scale 1 to 8 and check this view again here. The spacing between views, we can define it from this button here, the activation view, so you can control the spacing between views. So if we make it 0, for example, and click on create, those two views will be with 0 spacing between them. So if you would like to increase this spacing, you can define it from the activate view. Let's make it 6 and let's move it a little bit up. So from here, let's change the Y location to make it 28 and click create. Now let's add some dimensions to this saddle. Like let's add a center line here, and let's add dimension for the contact angle of the saddle and the wear plate and the contact angle of the saddle. So select this point, center point, and that point. Sorry. Let's select this one, and this point to define the saddle contact angle. Now let's define the height of the saddle, the height of each rib like this, the thickness of the base plate, the wear plate width, base plate width. So let's move this title a little bit below here. Oops. If you would like to add the center line of holes, you can add it on this view and define the spacing like that, and the width thickness, the wear plate thickness. Okay, add some welding details, like if you would like to show the weld with the shell, so it's like that. So let's move this dimension a little bit here. Another weld detail for the saddle. Like that. Okay, so if you would like to make a detail for the cut here, but on a different level, not on the facing of the base plate, so you can make a cut here like that. Here, and if you would like to add some weld fillets, you can do it from here. So let's add a fillet weld and 8, so you can make a fillet weld like that. So many different options. You can make it after that by creating the drawing on Autodesk Inventor. You can make anything after that. Some more options after creating this drawing. You can add the balance, bill of material balance. So you can add the item number. So you should select the parts only, not structure, parts only, legacy. So you can select this. And if you check the bill of material, item 33, for example, item 33, which is a base plate, it's here. It is a base plate with length, width, and thickness and weight. Okay, so let's come back to the GA drawing. If you would like to add some standard welding details or some blocks, some other blocks. For example, let's add a key view for this vessel. So let's take that one as a key view. So from here, we will add this view from plan view like this. Let's change the scale and key plan. So let's move it down here. So now we have this key plan, and we need to add the north direction on it. So from here, let's open the welding or drawing resources, and from sketch samples, you have two different styles from north direction. That's one of them, and another one, which is that one of the north direction. And if you would like to add your own block, you can add it to this standard blocks. Here, the same for welding details. You could add that welding details here, like that. And that's for circumference welding lines. So if you would like to add it to your drawing, you can add it like this. Continue for the circumference welding lines, like that. And for longitudinal welding lines that we defined, which is that one. So you can define it like this. So that's the longitudinal welding line, and you could add your own styles like this. For the nozzle details, those are the welding styles, and you could modify it for each nozzle. So for example, if we come back to M3 here, we didn't define the welding style, so you can define it here and define the weld size to make it appear on the welding detail. Many different options to control the bill of material style and nozzle table style. If you would like to remove some columns and keep some columns only, so you have the ability to do that. Now in this training, we create the general arrangement, the 3D model of this equipment, and know how to make internal and external projection for nozzles, how to make same as element, how to add support trips for nozzles, how to make lifting lugs, make a detail for the forged hub with lips, and how to make a detail for it on Autodesk Inventor drawing, how to generate the bill of material here and checking it before exporting it to the drawing, how to make the update item number, how to generate the general arrangement drawing, and how to make a detailed drawing for the items. I hope we can cover a lot of points during this training, and if you have any questions or queries, kindly contact Fawzan and he will take care of that. Any other questions?
No, it might be good for now. We don't have any additional queries.
Hello?
Hello?
Hello, yes?
Hello?
Yes, I'm hearing you. You can ask.
Yes, sir. We don't have any queries right now.
Okay.
So we can close the session.
Okay, thank you so much for your time. Have a nice day.
Thank you, sir.
Okay. Fawzan, we will end this session, inshallah. Assalamu alaikum.
Thanks, Ahmed, for your time.